Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at a library for GDI Plus and saving graphics windows to file. So what is GDI Plus? GDI Plus is a graphics device interface within Windows. This allows programmers to write device-independent applications. The services of GDI Plus are exposed through a set of C++ classes. Today we are just going to look at how we can use the API of GDI Plus to save a graphics window to an image file on disk. We're going to do that by creating a library you can include in your PowerBasic console or Windows applications. We're going to revisit some code we created some time ago that created a contact simulator using a graphics window to enable the code to be compiled and run under either the Windows or console compilers. This contact simulator allows you to monitor a number of houses or social environments, and the people that live and work around them, tracking contacts between them, and possible infections and how they might spread. I'm not an epidemiologist, but this application was a good way to demonstrate some of the things that PowerBasic can do within a graphics window using graphics commands. If we attempt to run our contact simulator, we'll see that the simulation here is tracking 5 houses or social environments, with currently 30 people tracked per house. We're briefly going to run this simulation and outline what we want our new library to do. As you can see from the screen, there's a great deal happening. The number of infections is actually monitored on a day-by-day basis over a period of 14 days. What I want to do with this application is at the end of each completed day to save the image that's currently on screen within the graphics window to a graphics file. So let's have a look at the code to see how we can do this. The pbmain function within our application is the place to begin. This is where all the information is actually prepared to run our simulation. There is a for next loop running from the first day to the 14th day of the simulation. You can run the simulation for more or less days by amending the max days constant. So before we start the next day, we want to save the current contents of our graphics screen to a disk file. This will allow you within your applications to generate image files at any point within your application. So you could have a console application whose sole task in life is to generate images. So how can we make use of this GDI Plus library? In the menu at the top of our screen, we have the Options setting. The Options setting allows you to set where the compiler is going to be looking for its Windows API include files. There are 2 different sets of Windows API include files, the set that ships with PowerBasic itself, and the set that Jose Roca has actually provided. When you're preparing your application for compilation, you can decide which of these 2 API libraries you wish to use. Today we're going to leave the Windows API include files to be the standard ones that come with PowerBasic. And we're going to be using a cut down library to access just the bits of the GDI Plus that we need for our current task. So if we have a look at the library I've created for this function, there is a simple subroutine called GDI Plus Save Image. This new subroutine takes a mere 2 parameters. The first being the image format that you wish to create, and the second parameter being the name of the file and the path to the file you wish to save. So before we have a look at the contents of this new subroutine, let's try plugging it into our application and see how it functions. So we can slot in the call to our new subroutine at the end of our for next loop before the next day is actually executed. So we're calling the sub GDI plus save image. We're passing it two parameters, the first parameter being the type of the graphics image we wish to create, and the second parameter is the name and the path of the file we're creating. I've created an images folder inside the folder containing our application, and our file is going to be called the word day underline and then the string conversion of the day number, a number between 1 and 14, and the extension is going to be JPEG. So if we try compiling that now, it will compile quite cleanly and we can try running our application. Although we're currently compiling using the console compiler, the exact same source code will compile just as easily underneath the Windows compiler. So I've put on screen the images folder. This is the folder that's going to contain our image at the end of the day, if the call to our save image GDI plus routine actually functions. So we'll fast forward now until the end of day 1. And there is day 1 completed, and we now have a day 1 JPEG sitting in the images folder. Note that what's being saved here is not a dump of what's on screen. It's a dump of the information held within the graphics control itself. If we open up our JPEG, we will see this contains the image at the end of day 1. And the application will go on, and at the end of each day it will save the next file. And there is our day 2 file appearing. If we open that one up, we will see it contains the image at the end of day 2. So we have successfully saved our current graphics control to a disk file. So let's stop our application running now and have a look at the code itself in the library. So we're calling this subroutine GDI plus save image. If we have a look at the subroutine itself, we'll see there's a number of things it's actually doing. It's taking in two parameters at the beginning of our routine, the image format and the path and name to the file as a wstring-z. We have a few local variables created at the top of this subroutine, but the parts after that are the important ones. We're creating a handle for the graphics device context, and we're using the graphic getDC to that variable. Picking up this handle will allow you to use Windows API functions on our graphics control. We can then determine the size of the graphics control by using the getCanvas command. This returns two values, the width and the height of our image. We can then use the startup input GDI plus version, setting this to version 1. We next have to pull back a token value using the GDI plus startup routine. These are all parts of the Windows API for GDI plus. Then, dependent on the image format we've passed in, we can handle bitmaps, JPEGs, GIFs or PNG graphics. Next, we are picking up the encoder class ID, and we're using the GUID command to turn this in to an encoder class ID GUID. We can then obtain a bitmap handle from our graphics target, and we're now creating a GDI plus image from that bitmap. The purpose of these GDI routines is to allow you to actually grab information from the screen regardless of the type of the screen. It is in fact completely device independent. And the final API call we're making is the one that actually saves the image to the file using the image pointer we picked up earlier, the folder and name of the file we wish to create, and the encoder class ID. And at the end of this routine, we are cleaning up GDI Plus to dispose of the image we have created in memory and also cleaning up the graphics handle as well. And then at the end, we're closing down our access to GDI+. If you were performing a lot of actions within GDI+, you only need to actually have the GDI open at the beginning and the shutdown at the end. But as there is some time between each of our days processing, this works quite nicely. As you will see at the beginning of this library, there are a number of user-defined types set up to handle the information we're passing to GDI+. And even further down are the declaration of the functions within the GDI+.dll library itself. Using this cut-down GDI+ include library will allow you to access GDI+ from within your PowerBasic applications, either the Windows compiler or the console compiler, without having to use the advanced Windows API calls. And using this library will allow you to save the contents of any graphics control to disk at any point within your application. Hopefully you'll find this library useful in your applications, but that's it for today. Thank you for watching.